In our previous lesson, we talked about a few reminders about radicals. Radicals come from exponent of a power that's a fractional exponent. So we look at the indice, which would be located here with the radical, to see what the exponent is. If it's not written, it's applied to 2, and that's talking about the square root, which is the 1/2 power. Any other power that you're talking about, whether it's the third, fourth, fifth, and so on root, that would be to the 1 over that power. So this would be the cubed root, so that's to the 1/3 power. So we can undo them by thinking about the radical exponent and how to make that a 1. We also talked about we're solving radical equations. The goal is to get the radical alone, so the radical equals something. If you have 2 radicals in your equation, make sure you have 1 radical on each side of the equation so you can start undoing it. Undo the radical that you're given. So if it's the square root to the 1/2 power, you would square it. To the third root or the 1/3 power, you'd cube it. Fourth root or the 1/4 power, you'd put it to the 4th power and undo it that way. You perform the operations to solve for the variable like you normally do, and then check your solutions for extraneous solutions. We realize that not all the values that you solve for the variable work when you substitute it back into the original equation. So let's take a look at a couple examples. These examples can be found on the second page of your Unit 5 Day 16 notes, or you can just write them on a piece of paper as we go through. So our first equation is 3 equals 4 times the square root of x minus x. And again, our goal is to get the radical alone. So we're going to start undoing the right-hand side of the equation. So we're going to start with our variable of negative x and undo that. So we'll add x to each side. So that would give us 3 plus x equals 4 times the square root of x. Closer to getting the radical alone, we have to undo this multiplication. So let's divide each side of the equation by 4. So dividing it by 4, we'll undo this and we'll have the radical by itself. And dividing each of those other items by 4 is also like saying you're multiplying by 1/4. So we can write it as 3/4 plus x over 4, or we can write it in the factored form. Once the radical is alone, what we want to do is undo it. So this is a square root. To undo the square root, we would square it. So we're going to square each side of the equation. Well, by squaring it, we know that means that you have 2 of those items multiplied together. So I have 2 1/4 being multiplied together, and 2 3 plus x's being multiplied together. We also know that when we square a square root, or something to the 1/2 power squared, that makes an exponent of 1, so the right-hand side is just x. So we're going to simplify the left-hand side by multiplying it. 1/4 times 1/4, that's 1/16. And by multiplying our 2 sets of parentheses squared, we would have our 9 plus 3x plus 3x plus x squared. Again, we've got some like terms here that we can combine. The 2 3x's would make 6x. And then we can also distribute through the 1/16. Remember, as we're multiplying fractions, the numerators get multiplied, then the denominators get multiplied, and see what you can divide out. So we'll have 1/16 x squared. This would be 6/16. You could divide out a 2 from each, which results in 3/8. And then we have our 9/16. So here we have an equation that we could start solving. And we can see that it's a quadratic equation. And when we solve quadratic equations, we want to make sure they're in standard form to have it equal to 0. So in order to do that, we're going to have to subtract x from each side to make it equal to 0. So again, we're working with fractions, so this is eighths. We would think of this as 8/8. 3/8 minus 8/8 would be our negative 5/8. So here's our quadratic equation in standard form. We have a couple ways that we can think about solving our quadratic equations. This is not one we can undo because we have the quadratic term and the linear term. We could ask ourselves, do we want to factor it, use the quadratic formula, or complete the square? Based on the fact that we have some fractions, perhaps we'd like to undo the fraction, the division, to make it no longer an issue. So if we think about fractions, adding, subtracting fractions, we should have a common denominator. If we look at our denominators, the common denominator would be 16. So I could distribute a 16 through the entire equation. So to undo that division, let's multiply each side by 16. And by doing so, this first term would be x squared, the second term would be negative 10x, and our third term would be 9. This is a little bit easier to work with when we want to figure out, is this something we can factor, the quadratic formula, or complete the square? So if we were thinking about factoring it, we could take the leading coefficient times the constant. What times what gives us 9, but adds to give us negative 10. If you want to do the quadratic formula, you could figure out coefficients. A is 1, B is negative 10, C is 9, substitute it and solve that way. You could also do completing the square, moving the constant to the other side, thinking about taking half that linear term, multiplying it by itself to what should be there to each side, and continue on. But if I think about factoring this, I could use a negative 9 and a negative 1 to make both of those items true. So for me, that's the quickest way of solving this. So again, looking at in pairs, I could divide out an x from the first pair and a negative 9 from the second pair. And I can see they have that common factor of x minus 9. So I could write this in factored form as x minus 9 times x minus 1 equals 0. What's nice about having it in factored form is that one of these two factors would have to be 0 in order for them to multiply to get 0. So I could take x minus 9 equals 0, solve that, or x minus 1 equals 0 and solve that and see what results. In doing so, we would end up with 9 and 1. Now, as always, we want to check and make sure that they're valid solutions to our problem. So we will take the 9 and the 1 and substitute them back into the original equations and see what results. So again, by substituting the 9 in, I can see I'll have 12 minus 9 equals 3. That's a true statement. By substituting the 1 in, 4 minus 1 is 3. That's a true statement. Therefore, I have two solutions to my equation, x equals 9 or x equals 1. Again, you could still end up with these two solutions, whether you solved it by the quadratic formula, factoring, or completing the square. All of those would give you the same results. Let's take a look at another. Here we've got the square root of 3x plus 7 plus 2 times the square root of x minus 8 equals 0. Again, when we're solving our radical equations, if we have two radicals on the same side of the equal sign, we want to separate them and move one to the other side. So in order to do this, what I could do is subtract 2 times the square root of x minus 8 from each side of my equation. Therefore, I would have the square root of 3x plus 7 equals negative 2 times the square root of x minus 8. Because we have a radical on each side of the equation, to undo that, we can square each side. So if we square each side of the equation, again, we know that something that's square rooted is to the 1/2 power. Well, 1/2 times 2, that's 1, so they undo each other. We'd have 3x plus 7 here on the left. Now again, we're squaring each item on the right-hand side of the equation. So we're taking negative 2 times negative 2, which is 4. And again, this quantity x minus 8 is to the 1/2 power, so 1/2 times 2 is 1. So we'll have it times x minus 8. So right now, this looks like a linear equation that we've been solving for quite some time. So first step, what you could do is you could distribute the 4 to your quantity x minus 8 to see what you're working with. Then your goal is to put the variables on one side, the constants on the other. Sometimes we suggest starting with the lowest variable, so this 3x. To undo that, we could subtract 3x from each side. So we'd have 7 equals x minus 32. Then we could add 32 to each side of our equation, which means x equals 39. Again, we have to check and verify that this works for the original equation. So we'll take 39 and substitute it in to see if it's balanced. Remember, we want it to equal 0. By substituting 39 in and simplifying according to order of operations, we can see that we've got some simplifying of radicals to do again. So find the largest perfect square factor. That means 2 square roots of 31 plus 2 square roots of 31 equals 0. Well, 2 square roots of 31 plus 2 square roots of 31 would be 4 square roots of 31. That does not equal 0. This is a false statement, so we would say that this has no solution. X equals 39 is what's known as a extraneous solution. It's the value of x we get when we're solving. However, when we substitute it back into the original equation, it does not work. It gives us a false statement. Here we have the cubed root of 2x plus 15 minus 3 halves times the cubed root of x equals 0. Again, the goal is when we're solving our radical equations is if we have multiple radicals on one side of the equation is to separate them. So let's add 3 halves times the cubed root of x to each side of the equation. Therefore, we have the cubed root of 2x plus 15 equals 3 halves times the cubed root of x. Now again, undo the radical. So if it's the cubed root, that means it's the 1/3 power. So if we cube it, 1/3 times 3, that's 1 again. That will undo the radicals. We just have to remember on the right-hand side that we're cubing the coefficient as well. So we're taking 3 halves times 3 halves times 3 halves. So that would simplify to 2x plus 15 equals 27/8 x. Again, here's another linear equation that we're going to solve. So we can start by combining our variables. Typically go with your lower one, so 2x, since it's positive, to undo that, you need a negative, so subtract 2x from each side. And so we'd have 15 equals, now this is in eighths, so we can think of this as eighths. So if we multiply by eighths, this would be a negative 16. So 27 minus 16, that would give us 11/8. So now we're going to undo what we have here for x. So since it's 11/8 times x, you have two options. You can multiply by the reciprocal 8/11 on each side to undo that. Because remember, this is like saying 11x divided by 8. So you're multiplying by 8 to undo the division, then you're going to divide by the 11 to undo the multiplication. That's where the 8/11 is coming from. So in doing so, again, multiplying across to simplify what you have 120/11. We're going to check and make sure that this is valid. I would leave it as a fraction as you're checking as opposed to a decimal because this is the exact value. It will help you with your calculations. So if we substitute it back to the original equation, simplify what's underneath the radicals, you can find their values. So again, if you want to use the cubed root on your calculator, you can do that. Just make sure you're putting parentheses around what's underneath the radical, and that will help you. Also put parentheses around your 3 halves or use 1.5 to represent it. But we can see when we take the cubed root of 405/11 minus 3 halves of the cubed root of 120/11, that will give us 0. If you can't find the cubed root on your calculator, you can also put this to the 1/3 power minus 3 halves times this to the 1/3 power, and that will accomplish the same goal. So because it's true, we have a solution to our equation, 120/11. Here we have equation, the square root of x plus the square root of x plus 3 equals 3. Again, because we have multiple radicals in the equation, we want to separate them. So one way in doing that is we could subtract the square root of x from each side of the equation. Now that we have a radical on each side, we can square each side of the equation and see what results. Squaring a radical will undo it. But we have to be careful on the right-hand side because we have two items that are being squared. So we're going to think about this as 3 minus the square root of x times 3 minus the square root of x. We know we have to distribute, so 3 times 3 is 9. 3 times the negative square root of x is going to be a negative 3 square root of x. Negative square root of x times 3, that would be a negative 3 square root of x. A negative times a negative is a positive, and the square root of x times the square root of x Remember, that's the square root of x squared undoes itself to give you just x. So at this point, we're looking to combine like terms. We can see we've got these that we can combine on the right-hand side. So we've got x minus 3 equals 9 minus 6 square roots of x plus x. Continue combining like terms. Well, we can start with our variables. So we want to put the x's together. We can subtract x from each side. Then we want to combine the constants, because again, we're trying to get that radical by itself. So perhaps subtract 9 from each side. To get the radical by itself, we have to undo this multiplication. So let's divide by negative 6 on each side of the equation. So we have 1 equals the square root of x. Well, we still have a radical to undo, so to undo the square root, we can square it. So then we'll have 1 equals x. All we have left to do is to check by substituting that back into the original equation and see if it's valid. So let's see, I'll have 1 plus the square root of 4 equals 3. I know the square root of 4 has a value of 2 and the square root of 1 is 1. 1 plus 2 equals 3. It's true, therefore x equals 1 is a solution to your equation. Last equation, 3 plus the square root of x equals the square root of x plus 81. So again, solving the radicals, we want to make sure if there's multiples, there's 1 on each side of the equation, which there is. To undo a square root, that's something to the 1/2 power, we're going to square it. So we know on the right-hand side, these will undo and we'll be left with x plus 81. On the left-hand side, remember, there's 2 of these being multiplied together. So we're going to have some distributing to do. When we distribute, we'll end up with 9 plus 6 times the square root of x plus x. Remember, this comes from the square root of x times the square root of x. That's like the square root of x squared. They undo. So with these terms combined on the left-hand side, let's start combining them across the equation. So here we have x. To undo that, we could subtract it from each side. Then we could subtract 9 from each side. And we have to undo the multiplication. So let's divide by 6 on each side of the equation. That would leave us with the square root of x equals 12. So we have to undo this radical. So again, this is to the 1/2 power. We're going to square it. So we're squaring each side of the equation. So x equals 144. All we have to do is check. Take the value of x and substitute it back into the original equation and see if it's balanced. Well, I know the square root of 144, that's 12, and the square root of 144 plus 81, that's 225. The square root of 225 is 15. 3 and 12 does give me 15. That's a true statement. Therefore, x equals 144. Now that we've done more practice with solving our radical equations by undoing them, using methods that we've done in the past, it's your turn to practice some problems. So again, these are found at the bottom of your day 16 in your notes. I also have them posted here. You are to pick 5 of the 8 problems and solve them on a piece of paper. The jumbled answers below are for all the problems that you see, so it should tell you whether or not you're on target. You have to remember, though, you have to check all the values that you get for solving for your variable to make sure that they are valid for your equation. If they are not true, you cannot use it. They're known as extraneous. If none of the solutions work for the problem, you would say the problem had no solution.